When I was preparing for this TED Talk, I knew I did not want to talk about myself. Coming up with the subject that I'm going to present to you today was very difficult, so ultimately I went with the best topic I could think of. My 6th grade persuasive essay on invisibility existing in real life. I did put a lot of effort into researching this topic, so I'm just going to go for it. If any of you came here to escape physics, I'm so sorry. The concept of invisibility is fascinating, right? Say yes. It has been prominently featured in sci-fi films, and it's a great fictional concept. But the possibility of making things invisible in reality is absurd. Or is it? Can you or I be invisible? Am I invisible right now? To understand how invisibility could be applied in our day-to-day lives,
J. Sadler to the office. P.J. Sadler to the office, please.
it is essential that we first examine the process of perception. How do we see? Consider how we distinguish between a plate and a bowl, or between me and Barney the dinosaur, although it's true that the resemblances between us are uncanny. Consider how we perceive color or see reflection. For those of you that did not take biology or that did not pay attention in elementary school science, let me break it down for you. When light reflects off an object, it enters the eye through the cornea, which regulates the amount of light that is absorbed. Subsequently, this light reaches the retina at the back of the eye, where it is converted into electrical signals that travel along the optic nerve to the brain, enabling us to perceive our surroundings, yada yada. Okay, light bounces off an object, enters the eye, and goes to the brain. Simple. When thinking about the inability to see things, it becomes evident that light plays a critical role in this phenomenon. As I began brainstorming ways that light, or the lack of it, could enable the possibility of making things invisible, I immediately came up with a few situations where this could be hypothetically possible. Situation 1. What if, metaphorically and physically, we turned off the lights? If there's no light, then it can't bounce off objects, right? You can't see anything in the dark. However, it is actually impossible to remove light completely from an environment in this context. I hope I don't have to explain to you why this is not an efficient way to make things invisible. So, if we can't eliminate light from the process, what else do we eliminate? Our eyes? Our brain? Close. Our next step would be to eliminate reflection, another crucial part of our perception process. This brings us to situation 2. In this hypothetical, light would pass directly through an object and reflect off something behind it, giving the illusion that the object is blending into the background. Have you ever walked into a glass door? Me neither. This is because although light passes through glass, making it transparent, it still reflects off the surface of the material, preventing it from being completely invisible. And here's the thing. No naturally occurring substance or material will ever be completely transparent. There will always always be some degree of reflection or absorption of light, which creates visible irregularities and interruptions in the flow of light waves when they flow from one substance to the other. This next experiment, however, quickly proved me wrong. At first glance, this appears to be just a container of oil until a glass test tube is pulled seemingly out of thin air. The test tube becomes visible when it is removed from the oil, but while submerged in the substance, it becomes invisible. How is it that light seems to reflect off the surface of the glass while it is surrounded by air, but not while it is surrounded by oil? It has everything to do with the way light bends off a material. Since it's different for each substance, the measurement for this is called the refractive index. Test tube glass and air actually have very different refractive indexes, which creates visible irregularities in the flow of light waves when they flow from one substance to the other. Interestingly enough, however, vegetable oil and test tube glass actually have a very similar refractive index, which means that there are minimal to no interruptions in the flow of light waves when they flow through the substances. This explains the seemingly invisible glass in the experiment. Okay, this is fascinating and all, but you know that's not why I'm here. I need to honor my 6th grade presentation that won me a $20 gift card. I need to tell you whether invisibility is possible in real life. No hypotheticals, no beating around the bush. To put it simply, yes, it is possible. Remember when I said that no naturally occurring substance or material would ever be completely transparent? That was true. But of course, humans have invented something called metamaterials, which are essentially materials with weird refractive indexes. Picture this: a material that reacts with light in weird ways. A material with a negative refractive index. You heard that right. Instead of light bending off an object, it can actually bend around it and pass by with no interruptions. So, if no naturally occurring substance or material can ever be truly transparent, can an artificially occurring substance or material do that? Also, no. I'm giving a TED talk, not performing miracles. What metamaterials can do, however, is bend light around themselves and the objects behind them, like a shield, an invisibility shield. You see, metamaterials are engineered specifically down to the atom structure. They are unlike naturally occurring materials in the way that they can make light go around themselves and the materials behind them, giving the illusion that there's nothing behind it. This phenomenon may still be under development, but the results are promising. So, do you think these following images are real-life examples of invisibility? How do we know to trust them? These following images may seem like stock images that I found illegally off a sketchy website, but they are actually an experiment conducted by the University of Rochester. This is a stock image I found by means of a singular Google search. And this is a WikiHow tutorial creatively titled How to Hide. In conclusion, while complete invisibility as seen in movies remains just that, a fantasy, scientific achievements are bringing us closer to that concept. Our understanding of light and metamaterials may lead us to invisibility shields and more, which could transform the physics branch of science as we know it. This picture may be an April Fool's joke conducted by an American university, but me and my 6th grade point still stand. Thank you.